Testing.
So let's get started. So today we'll definitely end our topic 1. So I will upload the assignment 1 to the Blackboard today, and I'll probably give you 10 days to do the homework. So probably next Friday will be the deadline for the homework 1. It shouldn't take you more than an hour for the homework, so shouldn't be difficult. So let's today what we will be doing is finish this Excel. We'll go to Excel, finish the Excel. We'll go to the go over everything we need, and then we start with the probability. Okay, so you'll be doing the homework, because the homework will be consist of 3 questions. The first 2 questions will be calculating summary statistics as we have done. You use it by hand, and the third question will be asking you to do Excel. Okay. So just before we start, is there any question? Is there any question? If no, then we will start with Excel. Okay. So just a reminder how we do it, right? Excel will be, everything can be with a formula, right? Equation, we start with equal, right? And if you don't put equal, then it's not doing any calculation. So everything will be Excel will have to start with equal if you want to do any calculation. If you don't start with equal, they will consider as a text. So don't do any calculation. And we have a function called square root and exponential. Square root we'll use it, but exponential we will wait it until the topic 3. And then we'll do the count, and the sum will be useful and you want to count things and sum of the stuff. And this one a little bit skip is a run up and run down, right? And just to explicitly what it says, right? And we have, for mean, we have average, and then for geometric harmonic, we have geomean and harmean. And this is to calculate the weighted sum, okay? So called sum product. And this median gives you the median, okay? And this is the summary of what have been done in the class, right? We do it in the main slides, and this is how you do the calculation here. And we learn referencing is to no need to write things in the formula, right? But you know how to do in the formula, okay? And we learn how to define name, because when you define names, and things become more clear than just cell reference. Okay, sometimes it's better to use the define name. This is more aligned with a classical idea of writing a program, because you define variables. Okay, and more clear. Okay, I would say, if you want to do that. And here we know how to do a mode. Do look that the mode that Excel would define is different from what we define in the class, especially when everything have appear once. Here return 0 mode. And in this mode, doc single is unable to handle more than 1 mode. Okay, so that that is some drawback about Excel. It's a function, so it's not the basic one. Cannot do the cannot return more than 1 value. Okay, so range is calculated max minus mean, and IQR we use quantile exclude 1 and exclude 3 for Q1 and Q3. So the IQR will be this. Okay, and we know how to do the population variance and sample variance. Okay, and we do how to do standard deviation as well, and that help us to do the coefficient of variation. And the SKEW.P and SKEW will be talking about population skewness and sample skewness. So to remind you, you almost always use the sample skewness. So the SKEW.P just for properly just for fun, but mainly used in the SKEW-X. Okay, but with any spec, there shouldn't be any issue there. You can test it from Excel. You generate a big data set. Okay, randomly put in some number. You notice the SKEW-P and the SKEW should not be different. With n is big, right? The adjustment is screwed n times n minus 1 over n over 2. That would be very small when n is big. So shouldn't be an issue when n is big. It doesn't really matter which one you use, but you can see when I have a 5 data point, it can lead to very different result. Okay. For kurtosis, Excel only give you the sample excess version. Okay. If you really want a non-sample version, you need to write a code for yourself. You can start from scratch, or if you really want to work on it, you have to know B.B.A, which is beyond the scope of our class. I mean, because of a tight schedule. I mean, B.B.A will be very useful, but unfortunately, we don't do that. But instead, our class in the optional tutorial, you will do R and Python, where you can do it easily. Okay. The reason don't cover it is not because B.B.A is not important, but it's much easier to do it in R and Python. Although I would say, still in the applications, in many basic business applications, B.B.A is still a little better because there are a lot of people using. But if you go to a new company, they are more likely to accept new thinking, then Python R would be better. And very soon, probably R will be incorporate Excel, because I think Microsoft has some connection with the R development. So down the line, probably R will be there. But if you know Python, R, basically they can work with each other. Especially if you don't know Python, actually they can work with Excel easily. So it should not be an issue. So this is how you calculate from scratch, right? Everything, how to calculate kurtosis and excess kurtosis. Okay, I already saw everything there. You can take a look at this particular slide to see whether you understand all the information here, and you will be using this, all the command for your assignment 1. So if you confused when you do assignment 1, probably you want to see here to check back and to see how to do it. The next thing is, I think we pretty much stop here, right? Am I right? Pretty much stop here, right? So now the next thing I want to talk about is to consider how to draw a scatter plot, and then we will go to covariance, correlation. Okay. After that, I'll talk about Addin. Okay. So this Addin will be a way to simplify our process in terms of descriptive statistics, because of although the function is easy to do, but sometimes you don't want to type so many things. So Addin is a good way to simplify and streamline the process somehow. Okay. So let me start with the scatter plot. So we'll plot this graph. I mean, as I said, I mean, probably most of you know how to do it, but I just make sure that you don't, everyone in the same pace. Okay. So let's start with this spreadsheet. Let me save it first, because last time we don't save it and then it hang in the middle. So let me save it first to make sure that later I can upload it. Okay, I have X and Y. So do note that Excel when try to input, they would just put the first column as the x coordinate. So put x and y rather than yx. Otherwise, you have to change later. So that's easier for you to input data. So I just input some number here. I think maybe something like this. I mean, you don't have to follow exactly this, but that's how I try to work out this one. And what we're doing is scatter plot. So I just change the name of the spreadsheet here, just scatter plot. So I'm going to do for this, the plot is just I input the number here, and I would highlight the two column, or I just highlight the data I want to. The two ways to do it, but I would recommend you to highlight the two column. The reason is being that if you want to add more data, automatically you will adjust the plot. If you just highlight this and do the thing, then new data will not be reflected in the plot. So this is some minor tips that you may want to follow. So I have this, okay? And clearly, I don't know, you see clearly here I have a scatter, okay? I will just click this guy. And what kind of graph we want, we will probably want the first one. Okay, so this is a little bit too big. Okay. Maybe I will zoom a little bit to see data. Okay. So this allows us to have a scatter plot. Okay. So if I try to okay, you didn't include the new data. So anyway, just still keep the old data, but you just change number here. You just change the data there. So this is one of the good thing about Excel is when you change number, the plot change automatically. That is slightly better than other software where you have to change the data, you have to plot everything again. But how to do scatter plot? Okay. So we'll come back to this scatter plot idea at the end of our course when we talk about regression. Okay. But here is we just stop here. We will come back to this graph. Now the next thing I want to talk is to calculate the covariance.P and covariance.S as a population covariance and sample covariance. And then I will have a correlation. Okay. So that's what we do. I will copy this one because I will be doing this. Covariance and correlation. Okay. So I just take away this chart, no longer useful for us. So we have covariance, okay, with a pop version and the sample version, okay. And how to do that, right? The population version will be just covariance.P, okay? And then you highlight the two column. So it will be A2 up to A6, comma, B2 up to B6. Okay? So this is how we'll be doing the covariance.P population. The sample will be .P become .S. So that is how you can do that. Okay, so that would be the one we need to input. So let me do it again for the sample. Covariance.S. And instead of typing, we can just highlight the first column and the second column. Okay, that is how you can input. Okay, is there any question for the covariance? I hope it should be more or less clear. I upload this same as previous class. I upload this on the Blackboard. Okay, probably I'll upload this during the break. So, and again, I want correlation. Okay, correlation. And do note that correlation has only one version. Okay, So I can just use CORREL, correlation. Again, I have two columns here. Okay. So this gives us this answer. So this is 0.9. So just to remind you that it's always between -1 to 1 for correlation. So 0.9 means this is very close to a linear one. Okay, so it's positive. Okay. So I also want to show you that you can also, because the formula we said, right? It's the same as looking at the covariance over the their SD, right? Standard deviation. So let me show you the calculation here. So I can do it as the following: covariance.P, these two columns, okay, and divided by the product of their SD, right? So STDEV dot P, okay, of X times STDEVP column of Y. Okay. So here, just to remind you, what I'm doing here is I look at the fraction, right? The numerator is the covariance, okay, and the denominator are SD of X, okay, and SD of Y. Okay, so that is the other way to do it. Once I push the enter, you should see the result should be 0.905. Okay, because this is another way to calculate covariance. Okay, so I hope this is clear. Now I enter. Okay, so give me the same result. Okay, and of course you should see the same result when I use the formula that instead of the P, okay, I use everything in terms of S. So just basically all the dot P replaced by all the dot S, okay, and you should see the same. So everything I replace by dot P replaced by dot S, I would be seeing the same result. Okay. So I guess I hope this is it's clear how you will be able to calculate all this. Okay. Of course, you just use CORREL, but these two just trying to show you that this formula is exactly the same as what we teach. Okay. So you should be happy about that. And okay. So if there's no problem, I will talk about Addin. Okay, we'll do Addin. So so I think I have Addin. I would do descriptive Addin. I would do descriptive statistics. Okay. So let me enlarge it. Okay. Now what I'm going to do is I have a data set X1 and X2. Okay. This is two new column here. Okay. What I want to do is just randomly put in some number here. Okay. And I have another column. I just you don't have to follow me. I just randomly put in some number here. So I'm going to do, as I said, I will do Addin, which is trying to make it quicker to know the summary statistics of the two data set. Okay. How do we do it? I guess most of you are the Apple, but everything you can also find it will be in the data. Okay. And the data, if the Addin is there, you should be able to see what we call the data analytics, but it's not here yet. So what I'm going to do here is I go to File, But I think this is only for the window, but Mac, I think you can just find it here. If not, then you're doing window, then go to file, okay, and go to option, file option, and go to Addin, okay, and file option Addin. What we need is this analyst 2-pack, analysis 2-pack. So it's not active, inactive. So what you do is to go and then click this analyst 2-pack. Okay, click OK. Then you should see data analysis. Okay, if you run the Mac, then you can just I think the similar procedure there. You can find Addin. Okay, so so I don't know if any problem. I don't know the iPad have that, but if you're using the Mac, you should have that. Okay. So I try to go around to see if any question, because I think that would be a little bit easier. I think since from the last section, not sure you're able to handle that, but I just go around to see if any question. But using the laptop, then you should be able to see similar thing happening. Is that okay? Yeah, that's right. So not sure the iPad can do it, but yeah, that's what I have it. But if you're using the MacBook, then you should be able to see this thing. Okay. Let me know if any question. If Windows, then it should not be an issue. But the Mac, then probably you need to check it out. So don't worry for the assignment. I'm not asking you to do this for assignment, but I just let you know like this. Yeah. So for iPad user, probably you need to check out with your classmate to see how it is being done. Yeah. Addin. Oh, you don't download? No, not just download. Not here. Let's see. NS data is there. Let's see. Yeah. Let's see. Is it data? Yes, here. Yes, here. If you are Mac, then already you should be there already. You don't need to do that work if you're Mac. But if you're Windows, you have to go into and check out. Okay. So now, why we have to do this? Because this data analysis 2-pack will be useful basically for our whole course. Okay. Because they have very shortcut for things that we need to do. Of course, we do not need to have this because all the calculation in data analysis can be done in Excel. Okay. But that's faster. Okay, later you see this as faster, especially when you have a lot of data. Okay, so that's why we need to talk about that. I mean, especially if you buy the textbook, they will spend a lot of pages and time to talk about this. But anyway, let's follow tradition here. Okay, when you click this, you will see many things, and indeed, we will learn. We'll use most of the thing indeed for our class. So we should be able to understand what's going on. ANOVA we'll cover in the second to our last topic. Today we'll cover correlation, covariance, and descriptive statistics, right? And we will not do smoothing, we will not do full-T analysis, but we will do F sample test. We don't do the generator and percentile, but we will do regression. We don't do sampling, but t-test, FZ test, although we do everything. So basically, I think we will cover in our course, cover 75% to 80% of that. Okay, but I mean, if you understand whole class, then probably you should be able to understand everything almost. So that's why we need to talk about a little bit about that. So we start with descriptive statistics. That would be something not difficult. just click on the descriptive statistics and click OK. Okay. So always in this, you would be doing two things. You have to tell them what is your input data and where you want to output it. Okay, always the two part, right? Here you will see, here's the input part. Okay, and here's the blue one will be the output part. So there you can see always is in two different things. You first tell them what are the data you store. The second is where you want to output and what kind of output you want. Okay, so let's get started. Okay, so we start with the input. Okay, so in our case, our data are in terms of grouping, in terms of column, not in terms of row, right? Your data is stored in the column form, and which is convenient when you have data of long, right? Because the fact that if you ever try to look at Excel, Excel have more row than columns. Okay, you can see column is by number, sorry, row is by number, column by letters, right? So you will see they would expect you to have longer row bar than columns. Okay, so it is convenient in this case to store things by column. Okay, for our purpose. So that's why here is grouped by column. This is what we choose if our data is by row then by row. Okay, and you tell them where are your data. Okay, here we have a little arrow here. Just click this guy. Okay, and you highlight the two columns that would be the most convenient. Okay, just two columns. Okay, of course you can always tell them this is the case, but it's easier just to highlight the two columns. Okay, highlight two columns. Okay, and then once you're done, okay, because of the fact that the first two rows are the labels, right? So I just put labels in the first row. Okay, if there's no label in the first row, then you don't need to click it. Okay, you just this option just say whether you have the label in the first row. Okay, the next thing is to tell them where you should output your data. By default, is creating a new worksheet. Okay, but I think it's easiest for our purpose in our class to put it somewhere in the same spreadsheet. Okay, of course, when your data is big, then you want the new spreadsheet, but for purpose is it's easier to put it, say, somewhere here like column C. Okay, column C1. Okay, maybe D1 is better, just some space. Okay, D1. Okay, and because we're looking at summary statistics, we're going to click on summary statistics, and that's it. Okay, and you understand what do we mean by confidence for mean in topic 4 or topic 5. When you talk about interval estimation, you understand what's going on. Okay, but for now we just need this one. Okay, and case largest and case smallest is usually not our concern for the moment. Just telling you that if your data is long, it tell you what is the maximum, what's minimum, right? If you have to see first last, and first smallest, then it's just looking outlier, right? If you put two, give you two largest and two smallest, and for our purpose, we don't really need that. If you want, you can have that. Say, you can have that because you may want to calculate range. In that case, you want to have that. Okay. Then click OK. Okay. Once you click OK, then actually you output what we want. Okay. As you can see, you have the mean, you have SD. The standard error is the thing we don't talk about right now. We will learn this when you go to topic 5. That will be you know what's going on. So this one is something we don't really learn it at the moment. But we know median, we know mode, we know SD, we know variance, we know kurtosis, we know skewness, we know the range, we know mean, we know max, sum and account, largest number and the smallest number. Actually, we don't need larger, smallest because they have maximum, minimum already. But that is how you calculate, right? Especially you can output. If you have many columns, you can output everything quickly. Okay, so that is one good way to look at your data. Okay, especially you have many columns. Is that clear? I mean, just go around to see if you're able to handle this. I mean, for those who are using the laptop, but if you're using iPad, just try to see your classmate, someone next to you, or how they can able to do it. Is that okay? Okay, good. I'm sorry if you're using the Mac, but using the iPad, but I hope you understand what's going on. If you go home, I think you should have a computer, then you should be able to do it. Okay, and the reason we're doing it is faster. Okay, you can always use Excel spreadsheet to do whatever you want, but we just need to know how to do this much quicker way. Okay, I hope that's okay. If you have questions, just ask me. Okay, so we will do the remaining two parts, then we're done. Okay, because knowing how to handle this Addin is important, because you will be doing this for the other thing like regression, ANOVA. This thing will be much simpler using this. Of course, you can do it Excel calculation, but much easier. Okay. So the last thing I want to do is I want to go back to here, but what I want is I use the Addin to do the covariance and correlation. Okay. So I just copy this thing. Okay. But I will, instead of doing this, I will do Addin. Okay. I will do Addin to do covariance and correlation. Okay. So that's what I'm going to do. Okay. Just remember the number 3.16 and 3.95 and 0.9. Okay. So what I'm going to do is, instead of doing this, okay, I don't no longer do that, but let me do Addin. Okay, I will do Addin. So again, what I'm going to do is go to data and click data analysis. Okay, we'll do 2 times. First time I will do covariance. The second time I will do correlation. Okay. So let's do covariance first. Covariance, again, it divided into 2 parts, right? The first part is asking you to tell him the input. Okay. The second part is asking to do output. Okay. So even though this panel is rather complicated, but it's always divided into 2 parts. Upper part is input, the bottom part is output. Okay. Just tell them where is the input and tell them where's output, they give you the result. Okay. And again, our data is organized by column. Okay. Then it just we just tell them we are doing by column. Okay. And if the data is by row, then it's by row. Okay. It's very simple. And the input range again is just column A and column B, or you can just highlight this part, the same result would happen. Just being lazy, I just click 2 columns. Here I've labeled the first row, so just put it there. Okay. Now, where to output the data? Let's do it in D1. Okay, let's do it in D1. Okay. And then that's it. You just very simple. I just tell them all the inputs and click OK, then you're done. Okay. So it's more or less a dummy style thing, right? You don't need to type anything. Just click where the input, where the output, and you're done. Okay. So shouldn't be an issue, right? So you can see what I have is usually what we call this. This is called the covariance table. Okay? Covariance table, and you will notice this is number we end up with. This number end up with. Okay, probably asking what is it? Is it giving you the population one or the sample one? Okay, so look at the data you have is they give you is the population one. Okay, so you may say it's not that convenient, right? Because sometimes we actually want the population one. So the sample one, but the Excel only gives you the population one. Okay. So whether you want to use it, I don't know, but you would be actually using this when you have large sample, right? Because otherwise you just type it out, right? Type it out. So you're working on a large data set, then in that case, using population one would not be a big issue, right? Because if the data size is small, then of course why don't we just do covariance 2 column, right? Only when you have a lot of data set and huge, then probably you use it. And in that case, it doesn't really matter. Okay. And the next thing you would be interested in asking yourself is, what are these green objects here? Okay. Why have some green object here? Okay. And if you go back to the definition of covariance, okay, go back to the definition of covariance here. How we define the covariance. How we define covariance? Yeah, covariance, right? If X and the Y the same, say Y is X, okay? The same, then this is exactly the variance, right? Y same as X. So that means that this 2.96 is the covariance. So it's the variance of X. So to prove this is right, I showed this is the case. So variance.P, okay? And I highlight the first column, okay? That gives you 2.96, okay? So just to show you what's going on here, this variance P is 2.96. I do the covariance P of this 2 column, give you 3.16. If I do variance.P of the second column, Y, okay, this gives you 4.1. So this gives you the green thing, okay? And this gives you the yellow thing. Okay. I hope this is clear what it means. Okay. So that is the reason why you need to learn what the function they are, right? Understand when you look at the new software, you have to see whether they're population version or sample version, right? Because you don't really know what they're going on, right? So better, that's why you always want to know start from scratch. Either you read the manual or you start from there. Okay, this is correlation table. So is that okay? Is that okay? If okay, we go to the very last thing with the correlation table, okay? Or what we call correlation matrix sometimes. Just the same, go to data analysis. Okay, we choose correlation. Okay? And again, this is a 2-part table, right? The upper part is the input, okay? The bottom part is output, okay? So always this interface looks ugly, right? It's not very modern, right? Because you look at the OE nowadays, then this looks like very old-fashioned. But I mean, this has been old-fashioned for many years. I mean, I guess when I was a student like 20 years ago, exactly the same thing, okay? Now after 20 years ago, when I probably haven't born yet, but I mean, now the same thing, okay? There's no change. But just again, input and output, okay? Now going to go to repeat again. Our input are just 2 columns here, okay? For 2 columns, data in the column, then in column, we have label in the first row, label in the first row, okay? And output, where the output, we just put somewhere in here, maybe, okay? We just put here, okay? We just put in D6, okay? And click OK. Then this is what we want, okay? So this number we want, okay? And let's make it bigger because we want to see the decimal places, right? And you probably want to again ask what are the green thing, okay? But that shouldn't surprise you. The correlation and itself must be 1, right? The correlation, obviously, because you're plotting a straight line, okay? So just to make sure that you understand what's going on here, I do correlation, X and Y, it will give you this guy. If I put correlation X and X, okay, should be 1. Okay. I hope that will not surprise you when I do correlation YY. I should be seeing the same thing. Okay. So I hope now it's more or less clear what's going on. Okay. So if that's okay, then we end our topic 1, and then the homework will be released later today. I set the deadline to be 10 days afterward, maybe the end of this month, and only 3 questions. The first 2 questions, just do some calculations. The last question will be involving some Excel. Just ask you to write down the formula. So the first homework is very easy. Okay, don't think that the whole course is that easy. But because that's first class and you learned that before, mean, median, or the thing, but so that's why it's easy. Okay, so although the whole course is not very difficult, but don't underestimate the content a little bit. I mean, is there any question? Any question? I just go around last time to see if you have any problem, because afterward we'll be talking about probability. Okay, we're done with the topic 1. In case of any question, just raise. Of course, with iPad probably can't try, but I suggest try at home. Although we really don't require Addin to do things, but when you do ANOVA later regression, it's easier to do it. Of course, you can do it by hand or by Excel calculation, but it's easier to know this at the beginning rather than wait until the end. Any question? Any question? Just go around to see if any problem. Okay. If no, then just remaining 3 minutes. Let me talk a little bit about probability before the break. Maybe I just take some time. Any question? If no, then talk about probability. So probability, I don't think I have some time, just 1 or 2 minutes. Okay. But probably to explain a little bit about why we talk probability, right? So as you will see later, today we will be defining what the probability is. Okay. So as probably most of you would know, how we define probability is from the empirical observation, right? So usually we will say, we toss a coin, right? It's a fair coin. We will say half of the time you expect a tail, half of the time you expect a head, right? So we put 0.5 to probability of head, 0.5 probability of tail. The reason is being that is the common idea that if we're going to repeat this coin toasting activity many times, say of million times, 500,000 will be head, 500,000 will tail, right? Just say what we call relative frequency, the ratio, right? And that is the history of probability, right? Coming from something we can repeat a lot of time. Okay. So, but mathematically, there is a problem of to extend this to things that we don't familiar, right? For things tossing a coin, rolling a die, drawing a card from the deck, something you can imagine, right? But if something that we can't imagine, okay, and then it's hard to say, right? That is the idea of experiment and learning. Can we do probability, right? Because say now it's a COVID, right? That is comes in data and probability becomes important, right? Asking now the government deciding when to relax the restriction come from COVID or when to open up Hong Kong, right? And of course it involves probability, right? What if we open? What's probability that things become bad, right? What probability things become good, right? You weigh in cost and benefit, right? It's uncertain world, right? Okay, if you apply the idea of probability, okay, we can't work, right? We only can work, we're able to have a time machine. We open up Hong Kong, see what happened, okay? and go to time machine, we close down Hong Kong, see what happened, and repeat this a million times, and we can decide what the probability that we open up is going to go good, we're going to open up, it's going bad. Okay, and it had to rely on the idea that we can repeat the opening and closing in Hong Kong at this moment of time many times, right? But time cannot go back as far as our science know from Einstein, right? I mean, time cannot go back. Okay, so how can we do this, right? How can we do some estimation, right? And if you look at how the people said, right, it's just like we have some mathematical model, okay, to see what happened and look at data, try to estimate if we open up Hong Kong, what will be the spread of disease, right? And now the government say I need more data, right? What does that mean? Okay, at the end of this topic, we'll learn one important rule, which will be taught, I mean, after 1 or 2 class. You got Bayes' theorem. This is the most important theorem for this topic. We're trying to see if you have more data, how can we learn more about things? Okay, so you may consider a case you have some conjecture. If you open up that with that probability, and we keep doing data fit in and see how this number changes. Okay, and that underline many things that happen in the COVID scenario, right? Because you would do an RAT test or PCR test, right? And how many tests before you can go back to the society after you get the COVID, right? Or how many vaccine you need to take in order to save for things, right? All these things are based on data, right? And data is trying to guess what the unknown we want to know, right? And this important Bayes theorem is the idea of using data to learn uncertainty. Okay, so that is why we need to learn this. And remember our course code, right? I think our course code is business decision for statistical analysis for business decision, right? So that's the most important thing. I mean, of course, now everything looks weird to you because we haven't learned anything yet. Okay, but that will be the main goal for this topic. And of course, also this builds the foundation for the next topic, random variable. Okay, but I hope it's clear what we're going to do is trying to extend our classical idea of probability as what we call the relative frequency. Okay, how many outcome the favorable event over total number of things is the thing you learn in high school, and we are going to extend it to a more general idea of probability. Then we can apply the probability in more context and we learn a particular application of how to take data to improve our probability measurement. Okay, let's have a break. We'll talk to you in 10 to 15 minutes afterward. Okay, so let's have a break. I think once 我即係覺得如果你交學費咁樣係可以People in the Zoom, you have any question? Good. So we will be starting in a minute. Okay, so let's get started. So we're going to do today, as I said before the break, is we will talk about probability. So we start with a classical definition that fit our intuition, and then we have to define probability that avoid that classical definition. Okay, because that will extend the idea probability to case where the old idea of repeating things wouldn't work now that well. Okay. So probability. So we start the probability with idea of random experiment. The reason being that, as I said, that's how probability starts, right? If you happen to know probability, how it start from gambling, right? Because that gambling thing is an important thing for the old days for the nobles, right? Noble people, rich people, they are having gamble for fun, right? And at that time, most of people want to understand what is a fair gamble, right? Because they play gamble with each other. They want to talk about fair gamble, okay? And because gamble is able to repeat itself many times, so naturally arise the question is to generalize this is to what we call random experiment. Random experiment is what we call something is going to happen, okay? And we don't know which one will happen, but we know what might happen, okay? And you can repeat. Just like tossing a coin, okay? We don't know whether I toss a coin, whether it's head or tail, okay? But it will be either tail or head, right? I don't know which one's likely, but it wouldn't be surprised me if I toss a coin, it come or die. Or toss a coin, it disappear, right? It's not a magic. So I toss a coin and gone, right? It's not going to happen like this. I toss a coin, it'll be head or tail, okay? Or roll a die, okay? You will be end up with a number from 1 to 6. It's a 6-faced dice. You will not be disappear, right? You will not vanish into thin air. It will be something we know the outcome, okay? So there will be something we know, okay? And then we define outcome. Outcome is what we call a possibility from a random experiment. Toss a coin is a head, and tail also outcome. Okay. Just to talk about some philosophy idea behind random experiment as a side note. Okay. Some of you may study physics or have an idea what we call deterministic philosophy about the world, right? You would think everything is deterministic when you toss a coin. If we know how much force you apply to the coin, what is the weighting, what is the direction where you hit the coin, then you already know the coin end up in head or tail. Okay, if you believe it's the deterministic idea, there's nothing in this world is probabilistic. It's deterministic, but we just don't know, right? If we know where I hit the coin, how much force I apply to it, if I know everything exactly, then there's no uncertainty, right? At least to, if no physics, at least to the macroscopic world, there's no uncertainty, right? Of course, we know there's a quantum mechanics when they go to very fine things and we cannot measure everything imprecise, right? There's a principal uncertainty there, but that is not, but at least in the macro, right? I mean, if I know everything clearly, then you can calculate, right? There's no uncertainty in that perspective. But do note that in the real world, we don't have all the information for everything, right? We don't know where I hit the coin, right? So at the end, because of we don't know enough, right? Even though the world is deterministic, we have missing some information, end up is being like random, okay? Even your mind thing is deterministic, but since we cannot collect all the information all the time, we're missing some information. At the end, the world behave as if probabilistic, okay? So here we didn't go put ourselves into the argument in the philosophical sense, but just to let you know that probability can, even though everything is deterministic, if the information is not sufficient, right, then we will still have that, okay? So just a side note, if you care, don't care, okay? But in terms of probability, there's a lot of deep philosophy behind what is probability, okay? We just sidetrack it because of business school, right? Just, okay, this is what we have, okay, probability, okay? And that's it. And the next two is very simple. Event, just a group of outcomes, any arbitrary group of outcomes. So roll a die, I have even number is an event that groups outcomes 2, 4, and 6. Okay. Another example is I have large numbers is an event that I group outcomes like 4, 5, 6, say. Or I have a prime number event that I group outcome 2, 3, and 5. Okay, so that is, you can group anything together, then it's called event. Okay, and sample space will be an event that consists of all possible outcomes. Okay, and say tossing a coin, head and tail together is the sample space because that is the only possible outcome we allow. And rolling a die, the sample space is 1, 2, 3, 4, 5, 6. Okay, so we assume we have full knowledge about this sample space, right? And because we're talking about random experiment, it repeats a lot of times, so that's why even though things very unlikely, it will appear. Okay, so we have full knowledge about that, and that's why comes to the what we call the classical definition, also a definition you learn in the high school, or what you can observe in your intuitive sense, is supposed to repeat this experiment many times. Okay, and then probability for an event will be a ratio. The denominator is how many times you repeat this experiment. Okay, and the numerator will be the number of outcomes that favorable to the event is related to the event. Okay, and we don't show it, but you should able to see, at least in empirical sense, this ratio tend to be stable. Okay, you can see if you just try to do it by yourself, take a coin, actually do it in high school, right? You toss a coin once, either your head or tail happen. If you toss coin 5 times or 10 times, it's likely that number of head and tail is more or less equal to each other. If you try more times, 1,000,000 times, 1,000 times, 10 times, and you will see if the coin is fair, half of the time is head, half of the time is tail. Okay, 500,000 would be that. And by definition, that would be probably the 1/2 is head, probably 1/2 is tail. Okay, because number of outcome favorable to the head will be similar to half of it. Okay, and this is useful, right? If you consider this ratio, okay, this fraction is going to be stable. Okay, we didn't prove it, but if you learn advanced probability theory using something related to what we call law of large number, you can actually prove that, at least prove it, the probability things you observe from here is actually very close to what actually is in the real world. Okay, so this is capturing from doing an experiment is the right way to approach this problem. Okay, but we are justifying from the physics or experiment point of view. So this number we know in the real world tend to be stable if you repeat many times. Okay, so that's why this measurement is a stable measurement. We can use it for our real world, right? That is the idea of casino, right? Casino, how they can make sure that they are going to break even or making profit, right? Is make sure that if you repeat many times, the probability is the right measure, right? So there's a famous quotation, but you guys are young, is but from the owner of the casinos in Macau, they said they would not worry about whether you're smart. Okay, don't worry about you're rich or poor. They only worry about you don't come back. Okay, why is the case? Because the probability is in their favor. Okay, whether you're rich, you're poor, you are smart, you're dumb, doesn't really matter, because the probability will work in their favor, right? If you repeat this many times, everything will be followed by the probability rule, right? If you're lucky, you may win once or twice, but the casino is playing with many people, right? So at the end, this thing will work as long as the probability is working in their favor, right? Then you will be gained, right? Say, if the coin is fair, but you know the casino coin is slightly unfair, right? So you're buying like not half of half, right? Maybe usually you will see, the casino is more likely to win. It's like 0.51 something, slightly bigger, slightly unfair. That is by design, right? Like the lottery machine, and also the same. It's like it's by design you have slightly disadvantage towards the casino, but doesn't really matter. Someone win, but at the end of the day, there's enough people playing. They would be able to make profit. Okay. Now, just come some example of how we define event and sample space and probability. Here, roll a die, a fair die, and the fair die have 6 outcomes, 1 up to 6, right? All the integers there. So 1 is outcome, 2, 3, 4, 5, 6 are outcome. Okay, and 7 is not an outcome, and 0 is not an outcome, right? So that's why the sample space is everything we have. The outcomes is 1 up to 6, and this is the we can see the curved bracket there is a notation of set. Okay, so for those who don't know mathematics, that will come a little bit uncomfortable, but that is the way that how people use it in describing probabilities, using a curved bracket to for each element you have a comma, then separate each outcome. Okay, so I mean, you will familiarize yourself if you continue this study, but I write the way that most textbooks use it, so hopefully should not be too difficult. So even numbers are just E. Even number called E will be equal to 2, 4, and 6, right? Odd number will be 1, 3, 5, and large number will be 4, 5, 6. Okay. And how can we assess probability? Okay, and actually we do know that if there's a fair die, right, and every outcome is equally likely, that would be fair, right? So you have, if you repeat many times, 1/6 of time is 1, 1/6 of time 2, actually 1/6 for every outcome, right? So the probability of event E, right, how many outcomes are favorable to that, right, would be 3/6, right? Because half of them will be 2, 4, 6, half of them 1, 3, 5, right? So probability even, odd, and large are all 1/2. Okay, so because just adding up, right, how many of them, right? I hope that is clear. Okay, suppose you have 6 million row, right? You have 1 million is 1, 1 million is 2, 1 million is 3, right? So probability E will be 3 million over 6 million. Is that clear what's going on there? I hope it's clear, but I think you should learn it in your high school, but just make sure that no one have any knowledge or you forget after many summer holidays and winter holidays. So is that okay? Good. Now this is the diagram called Venn diagram. Usually also you appear in the set theory, because why we always call about set theory, but that is because the modern probability theory is built on the set theory. I mean, indeed, I mean, all the mathematics is built on set theory, but in particular probability theory, we will find set theory very useful. Okay, so that's why, but it doesn't really matter just a diagram. You don't need to know the name Venn diagram, but just a diagram, right? Here as a sample space, okay, we have all the outcome 1, 2, 3, 4, 5, 6 in this thing, because we know everything is here. Everything is not 1, 2, 3, 5, 6 is not in sample space, right? And we can group things, right? When I have event E, right, is a collection of outcome that is even number, which is 2, 4, and 6, right? And there's a odd number is 1, 3, 5, large number is 4, 5, 6. So later, this diagram will be very useful when I talk about operation on set. We talk about interset, complement, union. These are the things we'll talk about soon. But this diagram, bear in mind, will be very important to understand what's going on in this diagram. Okay, but this is just illustration of this. Okay. Now we consider the following cases. More complicated is if I roll a die twice instead of once. And an outcome, you can record it as the numbers that appear every time. Okay. But in that case, we would consider first time is 1, second time is 2, is different from first time is 2, second time is 1. Okay, it will be, that means I have 2, 1 is different from 1, 2. Okay, and usually I would be represented by pair of number. When I have pair of number, I have a bracket. So this is in mathematics. For those who know, this is called order pair. Or you can imagine I have a 2-dimensional vector, if you want technical meaning. But here 2, 1 and 1, 2 are the different. Okay, and some of you may think, what happens if I don't care, right? Is it the case that I only care about the sum of the number? Okay, or I even don't care about the order as long as 1 and 2 and 2 and 1 are the same. Okay, but when you care about, just like the stock market, right? You today go up by $1, okay? Tomorrow go down by $1, okay? To you, if you evaluate portfolio today, doesn't really matter. You go down today 1 and tomorrow go up by 1, right? Doesn't really matter the order, okay? In that case, you want to simplify the outcomes of the sample space, right? That is what we will do next class. We call random variable. That will be the main topic for the next one. So, but in now, we just talk about outcome in the very raw form. 2, 1 is different from 1, 2. Okay. If you want to simplify this, we will do it in the next class. So next topic. Sorry. Okay. So everything is there. So sample space here, I have 1, 2, 1, 1, 1, 2, up to 6, 6. Okay. You will see there will be 36 outcomes. Why 36? Because you can list in the table form, right? By 2-dimensional table, row and column. Okay. You have 6 rows and 6 columns, so we have 36. Okay. And the event, it will be more fun, right? And many things can be an event. Say, for example, the sum of 2 entries is less than 4. Okay. And this simple statement actually means just an event that consists of 3 outcomes: 1, 1, 1, 2, and 2, 1. Okay, because 2, 2 is already more than 4. Okay, just be careful when we use precisely less than, doesn't have to be equal. Okay, so if I want equal, it will be less than or equal to. Okay, we say less than is strict. Same as greater than in our class will be doesn't include equal to. Okay, if you want equal to, I will say explicitly. When I don't say it's not. Okay, just to be careful. We use this explicitly. Like you do the math, right? Greater than or equal to are different, right? Because you know from your high school math, right? I hope this is hopefully this made clear. This is greater than, this is greater than or equal to. This is less than, this is less than or equal to. So make sure that you will be very precise about this notation. Okay. So in that case, if you roll the die which is fair, okay, you expect every outcome is equally likely. Okay, we have 36 outcomes, all the outcome equally likely. So each outcome, if you repeat many times, every outcome will appear as a ratio of 1 over 36, right? So that's why we have 3 outcomes. That's 3 over 36. Okay, so that is 1 over 12. That is probability of this thing happen. Is that clear? Is that okay? So I hope that is not something complicated. Okay. Now we are going to talk about some operation on the events, okay? And the reason we need to define this, as I said, is probably next class, next week, we'll talk about how, hopefully this, I don't know whether we can do it this class, but we'll define what is probability, okay? And we don't need to rely on doing experiment, okay? We'll define it's just some number we put on event, okay? For each outcome or each event, we put some number there, okay? Just the function, nothing else, okay? That is probability. And we have to assign a number between 0 to 1, okay? And that satisfies certain property, okay? That we will be doing this kind of operation, okay? So just to repeat what we're doing is we learn some operation on these events, okay? And that is going to put some restriction on the number we assign to the events, right? Because probability, actually, later we learn is we put number to events, okay? What kind of restriction we put those, okay? I have to be following this, okay? And but these are the things that probably you would be not be too difficult, okay? So this operation on event is actually what we call set operation, intersection, union or complement, which you think a little bit difficult to understand, but if you learn set, this is actually coming from logic idea, okay? When you learn logic, that is actually related to the idea. The first one is called AND logic, and the AND. And the union is actually OR, okay? And the complement is actually NOT, okay? We'll define it very soon, but these three operations actually coming from the logical operation AND or NOT, okay? So AND means both of them are true, then it's true, right? Or mean one of them is true, then it's true. NOT is just opposite of what the logical value. True become false, false become true, right? So this is the idea, okay? So don't worry, I will define it clearly and you understand by example. It's not complicated, okay? And you will see we have to define this boring thing in order to understand how the modern probability is being defined, okay? So unfortunately, it's tend to be a little bit boring, but we can't skip it because it's how we define things we have to learn, okay? And that's the definition, okay? Intercept, okay, is you would be called all common outcome. That's why I call N, okay? It's just everything there, okay? So if I have a roll a fair die once, okay, and the sample space is 1 up to 6, right? And we can define how we define even number is 2, 4, 6, odd number is 1, 3, 5. Large is 4, 5, and 6, okay? So the question would be, how do we do the intersection, okay? Is to look at two sets. If there's a common element, it will be in that set. If not, it's not, okay? Very simple, just do step by step. If E and L, okay? Look at 2, okay? Is 2 appear also in L? No, it's not. Look at 4. Is 4 appear in L? Yes, then it's here. Look at 6. Is it appear in here? Yes, appear here. Go to L again. Is 4 in E? Yes. Is 5 in E? No, then no. 6 in E? Yes. So that's why end up with 4 and 6. Similarly, O and L, look at the common element, only 5. Okay. Now here I just omitted one thing. Okay. What is E and O? What is the intercept of E and O? Okay, it's nothing. Okay, there's no common element. So E and O will be empty set. Okay, but I didn't put it here, but you should know there's nothing in the E and O. Okay, is that okay? Just find all the common element. Okay, it's same as in the primary school. You learn what is common factor. Okay, finding common factor. Now, so if you look at the Venn diagram, The interset will be just the overlapping of region of the circle, right? The area. So you see the E have 2, 4, and 6, and L have 5, 4, 5, 6, right? And the overlapping area like this is called intercept. Okay. So nothing very deep, but you just need to know the definition. Is that okay? Okay. So next we go to the union. Again, the union is also very simple. Just include everything in both things, regardless they appear twice. Okay. It is very similar to the operation when you do in the primary school. It's called finding lowest common multiple. Put everything there. Okay, everything is put in there. Okay. So let's the example we have again roll a die EOL. Okay. Look at what is E and L. Okay. E union L. You just put everything there. Okay. You have 2, 4, 6. You have 4, 5, 6. Okay. You just write everything inside. Because of the definition of a set, if you have the same element, you can just take it out. Okay. So 2, 4, 6, 4, 5, 6. You don't need to repeat 4 again because to them it's the same. Okay. Because when I have this curly bracket set definition, repetition has no meaning. So you just put everything, just combine them together. And O and L, right? You put everything in both O and L, okay? And done. Okay? So you can tell me immediately what is E union O, even union odd, will be just exactly S. Let me repeat. Union E and O is just S. Because E and O is just 1, 2, 3, 4, 5, 6. Just S. Okay, so I hope that is clear. Now, E and O in terms of graphics, you just include everything, right? So just the whole thing. Okay, just if you draw a Venn diagram, just everything combine it. Okay, combine the graph. Okay, that's what this graph look like. I hope it's clear what we are doing. Okay, this is the set of E union L. Lastly, we have idea called complement. Okay, complement. Complement will be little bit tricky. It's just like you have to know the sample space. Okay, so basically just like a complement is everything not in A, but in the sample space. Okay, so what you do is look at the sample space. Okay, if I want E complement, what I do is I take out E from the sample space. So the sample space is 1 to 6, and E is 2, 4, 6. How to do E complement is look at the E. Okay, I kick out things that related to E. Okay, 2, 4, and 6 I kick out from the sample space. I kick it out. What left is 1, 3, and 5. Look at L is 4, 5, and 6. Right. So go to sample space. I kick out what is in L. I kick out 4, 5, and 6. So left 1, 2, 3. Okay. So ask yourself, what is the complement of O? Okay, or number. I kick out 1, 3, and 5. Is left is 2, 4, and 6 is even. Okay, so in this case, E complement is O, O complement is E. Okay, is that clear? So mathematically, you know, if you do complement twice, go back to yourself, right? Because each complement is odd, odd complement is even. So you complement twice is yourself. That is general thing, but we are not math class, so just in case you want to know, but that's what happened. Okay. Now this is what it means, complement, right? The E is 2, 4, and 6 inside. Everything outside 1, 3, 5 is its complement. So that is the idea. Okay, everything not within it. Okay, is that clear? Now, once we know this idea, union and complement, we'll define 3 different type of event, then we can define probability. Okay, let's see three things. There's a three special thing we'll be using it all the time. First is called mutually exclusive events. Okay, mutually exclusive. That is very simple. The idea is they cannot happen at the same time. Okay, that means that if I know one had happened, the other can't. Okay, because they can't at the same time. Okay, so example would be if you are in the New York here, you can't in the London. Okay, or if you are in New Territories, you cannot in Kowloon, you cannot in Hong Kong. Okay, but do note that it does not imply one of them will happen. Okay, so because you may not be in New Territories, right? And you can, so put it this way, New Territories and in Kowloon, right, are mutually exclusive, right? If you are in Kowloon, you cannot be in New Territories, right? If you're in New Territories, you cannot be in Kowloon, but you can be in Hong Kong Island. So both of them can be false. Okay, so it just excludes the idea that both are true. Okay, it doesn't exclude that both are false. Okay, is that clear? It just simply means the intercept is this notation is called empty, it's nothing. Okay, so let's see example. I think we have example here. Okay, just in terms of rolling a die, even number and odd number are mutually exclusive. Okay, so I hope that's clear. The next is very simple. It's exhaustive. It just means that one of them will happen. Okay, so one of them will happen. So it doesn't. It just It just means the union of everything in the sample space. Okay, so happy and not happy are exhaustive, right? Anything and its complement must be exhaustive, right? Because add up the sample space. Okay. This is a definition technically, right? One of them must be happen. Okay. And the next thing we'll define finally is combine two things. Is they are mutually exclusive and exhaustive. It's called partition. Okay, so it must be one of the things would happen. Okay, and it cannot be more than one happen. Okay, and what it means graphically is like this diagram. Okay, the sample space. Okay, you divide them into different regions, that is non-overlapping regions. Okay, so why they are not overlapping? Because they are mutually exclusive. Okay, and it is cut on the sample space because it is exhaustive, and that's called partition. It's a cutting them into many pieces. Okay, and if things happen, only one of them is true, and it must be one of them is true. Okay, it will be one and only one is true. Okay, so that is called partition. Okay, the partition is very important idea, and that is later when we talk about probability. That is what we call divide and conquer. Right, we divide the sample space into different parts, and we calculate parts by part. Okay, so that the idea of partition is very important. Okay, and I hope it's clear what the definition it means. Right, so we just divide it into multiple parts. And none of them, the intersection is empty, and the union of them is the sample space. Okay, so this is the most important definition right now, because we will need to define our idea of probability. Okay, we'll do it last 14 minutes. Okay, not 40 minutes, 7 minutes, I guess. Is that okay? Now, this example. So we have 1 to 6. the even number, odd number. Now I have a new thing called prime number, 255, and big number, big even number is 4 and 6. Okay. Now here you can see odd number and B are mutually exclusive. Okay, because the interset is empty, so there's no common element, right? And you will see O, P, and B are collective exhaustive because union of them is just sample space, because it must have, you can always find 1, 2, 3, 4, 5, 6 in one of them. Okay, at least more than one of them. Okay, and here you can see E and O, even and odd, are mutually exclusive and exhaustive because the union of them is sample space. The interset is just empty. Okay, that means that there's no common element there, and combine them is actually sample space. That's called partition, right? Mutually exclusive exhaustive is basically you have no common overlapping element, but it just combining them is just the sample space. Is that clear what's going on? Okay, now there's a time limit, but I want to quickly go over the probability so that you can end up with something. We'll probably explain more detail next class, but want to tell you this axiom of probability. That is actually a result. The definition comes from 1930 by mathematician, a Russian mathematician, Kolmogorov, in 1930s. And the classical idea of probability that as a ratio in the normal frequency is defined 300 years ago in the 1700s by French mathematician, right? But now here the definition is coming from modern probability theory. Okay, and so the probability by definition is just very simple. It's just a function from event to number. Okay, what I mean by is we're sample space. Okay, sample space consists of many outcomes. Okay, and we will say for any union, interset, complement operation on that. Okay, we will put a number there. Okay, and the number we'll define, the first thing is the number we put on the event must be between 0 to 1. Okay, why? Because probability is a fraction. We define in the old days, right? The fraction. So that's why we must have first thing to restrict is anything we want to put on an event, right? Put a number there. The number must be between 0 to 1. Okay, that is, I think it's very trivial, right? So something, it's just like we define probability. We put number must be number between 0 to 1, right? The negative probability has no meaning. More than 1 has no meaning, right? 1 is like sure happen. 0 is like nothing would happen. Negative, I don't know what's going to mean, but anyway, that is what it means at first axiom. And by axiomatic, this is like the mathematics idea. Is like we start with something, we just by assumption. Okay, we don't question why this is true. Okay, we justify by our intuition this is right. Okay, just think this is right, we don't prove it. Okay, we believe this is true. Okay, and that is the idea behind the modern mathematics or physics, right? We start with something we don't prove or we can't prove. This must be justified by experiment or by our human brain. Okay, that is what, or observation, that is must be one. The second one is also, I think, is rather trivial, but that has a lot of empirical content. This is saying that the sample space, the probability must be 1. Okay, so it does imply one thing is there is no surprise in terms of outcome, right? So that is what we define random experiment, right? Is we know what are the sample space, right? There's no surprise, right? That's like Roy. Remember the question is, we toss a coin, you must head or tail, cannot be disappear. Okay, roll a die, it must be 1 up to 6, cannot be a rabbit. Right? We are not doing magic, so that must be something. Okay, so sample space is 1 is the idea there. There's no surprise in terms of outcome. Okay, we may be surprised that outcome comes out. Okay, that's okay. Something unlikely comes out, that's fine. But it must be, we know all possible outcome is there. Okay, so that is the thing. Okay, now we come to the last one, that we only have 3 restrictions. This last restriction is the most important restriction. Okay, that will rely on our idea we call partition. So that's why we learn so many things about union, complement, intersection. We learn mutually exclusive. We learn exhaustive. We learn partition, because this is we are doing now. Okay. If an event A, okay, consists of outcomes that are mutually exclusive. Okay, outcomes. Okay. So just like roll a die, okay, and an even number consists of outcome 2, 4, and 6. Right? 2, 4, and 6 are mutually exclusive. Right? Because 2 happen, 4 can happen, 4 happen, 6 can happen. Right? So one of them will happen. Okay. And this is what mutually exclusive is, right? And this axiom means the following. It means that the probability of that event, okay, it just because they're mutually exclusive, it's just sum of those outcomes. Okay, put it this way, let me repeat the statement. If the event consists of several outcomes, okay, and these outcomes are mutually exclusive, so they cannot happen at the same time. Okay, if one happens, the other cannot. Okay, and the probability of that event is just probability, sum of these probability. So you look at probability of that event happen, and then look at them separately. Sum of this separate event should be same as original event. So there's no difference. Look at probability. You look at the whole event, or look at them separately. So that's allow us to do divide and conquer concept, right? If we don't have this, okay, then doing the calculation can be complicated, right? Because if the whole is not part of the sum of the parts, then you have to think very carefully, right? Everything you have to do separately. Okay, so here just like the probability whole is sum of its part. As long as the parts are some kind of unrelated, right? If the unrelated parts add together, the probability doesn't change. Okay, so it means when I talk about probability of an even number, okay, I can talk about probability of 2, probability 4, probability 6, right? And I don't have to worry about how they decompose each other. If I have to worry about when they divide, they decompose is different, and they combine different, then actually it's not going to work, right? And actually that fit our real world phenomenon, right? And we talk about probability of even number, just add up things. Okay, so this is the most important important axiom. Okay, we don't say why this is correct, right? But this, we believe this is the right thing. Okay, and that is what it is. And you may ask, this is very natural. Okay, so what does this buy us? Okay, and the key thing about this is the main thing. I mean, when n is finite, okay, technical point. When n is finite, this is very natural. Okay, when n is infinite, then it's not clear. Okay, that actually the real bite of it is, that's why it take 300 years to develop this. It's because of, we don't prove it. It is because of when this should be holding when we have infinite number of outcome combined together. Okay, when you believe the world is discrete, okay, doesn't really big thing. But when you believe the world there's some continuous thing there, then this will have bite. But we're not going to that point. We just end up here. Okay, so we will see you next week. Now you have your probability idea, so again you can sleep well. Okay, I will see you next week. Just remember, I upload the assignment today, and it will be due on the next Friday. Okay.